Great, example 5, we have a little bit different function. This time it's a little bit more complex. We still need to find the same thing. So our x-intercepts, we're going to go ahead and take our numerator and set it equal to 0. So I would have x cubed minus 7x squared plus 6x equals 0. And in order to solve this, I would factor out my GCF of an x. And then I would factor the next part. So I need to multiply to 6, but add to negative 7. So I would have x minus 6 and x minus 1. So I would set all of those all of those factors equal to 0. So I have x equals 0, x minus 6 equals 0, so x equals 6, and then minus 1 equals 0. So I get x equals 1. So my x-intercepts are x equals 0, x equals 1, and x equals 6. Okay. Vertical asymptotes. Before I find vertical asymptotes, you guys always find your holes first. So f of x. I already factored the numerator to do my x-intercept. So I have x minus 6, x minus 1, all over x minus 6. So do I have any holes? Yes, I do. Those cancel. So at x minus 6, so at x equals 6, I have my removable discontinuity, or my hole. And then whatever is left in your denominator is your vertical asymptote. In this case, there is nothing left, so none. D, the limit as x approaches 6 from the right. So the first thing I would do is I'd try and plug in 6, you guys, and I would see that there's an error. So then I would try and factor, and in this case I can, because it was a hole. So I did my factoring down here. So this would really become the limit as x approaches 6 from the right. And I would have, based off of this simplifying here, I'd have x minus 1. So you'd have to simplify it. And now, could you plug in 6? I could. I would have 6 times 6 minus 1, which is 30. And the same thing for the left in this case, since I can break it down and simplify, I would also get an answer of 30. Okay. So there is D and E. And then F, we need to go ahead and find the limit as you go to infinity. So the way we do that, you guys, is biggest degree in the numerator, we're going to divide, biggest degree in the denominator, we're going to divide everybody out, which is x. So I'm going to divide everybody by x. So I would have my limit as x approaches infinity. I'm taking out an x, so this simplifies. X cubed over x is x squared, minus 7x squared over x, so that would just leave me with 7x plus 6, all over, taking out an x, I'd have 1 minus 6 over x. Now the x's that I factored out would cancel. And I would have my limit as x approaches infinity. I have x squared minus 7x plus 6 all over 1 minus 6 over x. This piece right here, it's a constant over an infinity, or an x to some power. This would approach 0. This right here, though, this would be an infinity squared minus 7 times infinity plus 6. That would still remain to be infinity. So my numerator would be infinity over the number 1. So this one would be infinity. Okay. And if we're going to negative infinity, we would have the same work, you guys, except for here, this would be negative. And if I plug it in, we would still get a positive infinity result. Here I'd have a negative infinity squared would still be a positive infinity. And then I'd have negative 7 times a negative infinity, so it'd be plus infinity plus 6 over 1. So that's kind of like infinity over 1 again. So this is infinity. You can always check your answer here, you guys, by graphing it if you want to. So if I go to y equals, I'm going to clear out what I got, alpha f1. And so what do I got? I got x to the third minus 7x squared plus 6x. What happened here? Got in the bottom somehow. And then in the bottom, I would have x minus 6. All right, if I graph this one, looks like a parabola. Okay, sounds good. And as I go to infinity, my y values are going to continue to go to infinity. And as I go to the left, negative infinity, they're going to continue to go to infinity as well. So that matches up. And then you guys just remember, to get your window back to standard, you go zoom 6, which gets you to your standard window. Okay. And there it is, maybe graphed again. And then lastly, horizontal asymptotes. Okay, when I have infinities involved in both of those cases, there is no horizontal asymptote. Okay. And plus it's a parabola when I was done graphing it, so there is no horizontal asymptotes on that graph.